Hey guys, today on the bench we have a Ryobi Charge Center. It's the P113 Charger, and I have wrote on here, if you can see that, Johnson's Electronics 408. So it is like the previous battery repair. Probably came with the same kit. It's about 11 or over 11 years old, and I noticed that this charger has started, with every battery I try to charge, it starts saying defective pack, even if it's not defective. I've tried several packs and it does the same. I thought maybe we'd look into it and see what might be going on. Just taking the 4 little plugs out, little skid protective plugs, little rubber plugs. I'm gonna unplug it. I've also already taken all 4 of the security Torx screws out, so it's just 4 screws, and this comes apart. The first thing I'm going to try to do is get to the caps and make sure they're discharged. So especially my larger caps. Several here. Some of the bigger caps here. I can tell they have resistors across to help them bleed off, but you can't always rely on that, so just make sure. I'll make sure we get a little closer view of this board. I actually see one thing right off. Let me know if you see it too. It might be hard on camera to see it, but since it's giving me some issue even with good batteries, and you know it's sensing the battery voltage, I was going to definitely look in this area. It could definitely be something here with the filtering, but the way it's acting, like the charge is okay, it tests okay, it starts like it's going to charge, and then it's showing something with the pack. So I would assume it's either something with this sensing circuit or something that's outputting on the charger itself. So I just thought, I don't know about percentage wise, but I was thinking more likely it would be in this, on this side here. If you're not familiar with chargers, they're similar to switch mode power supplies, where we got our AC line coming in, an NTC hit a limit current coming in, got some filtering, some filter caps, bridge rectifier. As we come across here to switch mode high frequency transformer, we can see that we got some isolation here. So we got our low and our high side and our lower voltage side, which is where some of our surface mount stuff also is. So jumping the gap here, we got our transformer. We flip back over here, probably an optocoupler. It's actually the feedback for this circuit back, or right from the start. The way it's acting, I don't think it's a main component failure at this point, like an IC that, you know, it wouldn't be working at all right, or any feedback, it wouldn't try to work, I wouldn't think. So the first thing I would check, especially in the 11-year-old category, I was going to check the electrolytics. And what I was talking about earlier, as soon as I took it apart, I seen was this bulge cap right here. Now I'm going to try my best to make sure you can see that on video if you hadn't already spotted it. But this cap is very bulged. It's a Capson 1000 microfarad 50 volt. And it is a 105C rated cap, so nothing really wrong with the spec on that. Looks like it's away from heat. These are probably closer to heat, the larger filter, input filter caps, but they look okay physically. And that's not leaking, that's actually some type of goo, almost like a hot glue or a retaining compound to keep those in place, because you don't want to physically leak either. If they are around heat or start swelling, they can also truly leak the electrolyte out of it, so you can truly leak the fluid out on the board. Doesn't appear to be the case. I think for now I'm just gonna use this for a capacitance meter, because the 179 has been around and I've had these for a long time, but it's a pretty good capacitance meter. But we'll bring this 179 on set for capacitance, and we'll flip this over, and I'll go ahead and check these big boys first, even though they look okay and it's not on the side I'll be concerned about. But these are 330 microfarad at 200 volts, and looks like they are in series, so they could handle up to 400 volts, it looks like. Make sure you can see the meter. Yeah. Okay. 324, good. 339, great. Okay. Those are good. I'm going to go through and check a lot of the electrolytics. This one here is reading right at 50 microfarad. It is a 47 microfarad, so that's good. A 113 microfarad, and that one is rated for 100. 1.7 actually is a 1 microfarad. The C203 is picking up over 100. I think it is 100. I don't see any so far that bothers me with just capacitance checks, but we hadn't checked the one we think is bulged, or the one we know is bulged we think might be bad, is C201. And again, 201 is 1000 microfarad at 50 volts. So that's your main output filtering. The negative side is here on this capacitor, so we stay in polarity. We're getting under 1000 microfarad, so that might be a good sign. I'm going to bring over the ESR meter. Set this aside. Like it is pretty close to zero. We'll re-zero it with the leads anyway. And so the first one I want to check is this one I think is bad. And we see right off that we're at 21.2 ohms. So it says the reference for a 24 volt electrolytic cap is good if it's less than 4.7 microfarad. So even on the screen it's telling us unless that's a little cap, it's reading a little high. So at 21 ohms or so, if we just look at this chart here, we had if I would have went for 1000 at 50 volts, 0.07 or 0.05, somewhere in that area. So I'm going to bring over a brand new Nichicon 1000 microfarad 50 volt. And first, I will bring this back over and check the capacitance. So we're getting close to 1000 microfarad. Here's a brand new cap, so well within the tolerance. Very good brand too. Man, look at that. That's really good. Showing 0 or 0.01 is 0.005. Very good ESR in that Nichicon. So we do have a good replacement. Guys, after editing the video, I realized how poorly I did in the video on this new bench. I let my display get into the glare of the light instead of bringing it down. And also I tried to show this ESR chart here, and it actually was doing like it is now. It didn't want to focus, but sometimes you gotta manually help it. But even though the camera didn't focus well, the writing's so small that I really should have got out this chart here. And this is the chart that I previously used in like reviewing this meter and some other ESR videos. And it's just easier to see here that, for example, this is actually the faulty cap that I did a terrible job showing in circuit with the glare. I thought we'd just check it now and insert this in the video so you can see it a little better if you had any questions. So 1000 microfarad, this is 50 volts, so we're going to be in between these columns here. So kind of like we said with this chart here, we're going to be somewhere between 0.09 and 0.11 ohms at this rating. And with this one was, I believe was getting 20 something. We'll check it again. Again, I just removed this yesterday, so first of all, we'll put these together. It usually reads really, really close, so I won't zero it. It is showing 0. I'll even bring it up so we can see it a little better. So we're still showing about 17 to 18 ohms. And that's what I was referring to about sometimes it tells you the reference is good if it's for like a 25 volt electrolytic that's less than 4.7 microfarad. It's giving you that as a reference. So 4.7 right around here, yeah, 29 ohms will be okay for 4.7 at 25 volts. So it's saying if it's less than that, you're okay, because it don't know what you have hooked up. But we know that we don't have that. So if we look at the chart, we know where we should be. Let's say about 0.10. That was a dead giveaway on that cap that we had a bad ESR reading on that cap. And of course we take another new Nichicon 1000 microfarad at 50 volts. And we get a 0.01. And the other one was also 0.005 or 0.01. Very good ESR, very good caps. So I also could have brought over my little Yoso, the GM328, that I really do like. Both of these devices would absolutely caught this cap being bad. And it tells us we got an ESR of about 31, voltage loss of 27%, and that our capacitance itself is really low. We're supposed to be 1000. So I just wanted to be a little more clear on the ESR. I actually didn't talk about it a whole lot in the video, but ESR is the electrical resistance in series with the capacitor. So something has happened either with the connection or either the electrolyte has actually dried up to cause a series path of resistance in series with this capacitor, which either in itself affected the capacitance of it being able to read, or the capacitance filling itself caused it. So it could be drying out, it could be a bad electrical connection, the way that they're connected internally. So heat is a main cause, and of course just age. And I want to clarify also that ESR is the equivalent series resistance, not to be confused with one being leaky. If one's actually considered leaky, then it has a parallel resistance in it. So something between the two plates, which drying can also cause, but it's a resistance between the two plates. So it's actually the opposite. Instead of being series, it's actually in parallel. That's when you consider one leaky. And that's also not to get confused with one being physically leaky, which sometimes on a board you may see where electrolyte has leaked out of electrolytic capacitor and actually have a little oil spot or corrosion on a board from it, because it is corrosive. So physically leaky, not to be confused with being electrical leaky, And the parallel leakiness, not to be confused with the ESR, which is series resistance. So I hope that helps, and hopefully it's a little bit clearer with the display being seen. I want to go through and check these others while I got it apart. Just check these big caps because it should be really low. Yeah, 0.05. 0.06, 0.07, and those are the 330 microfarad. So it's in between here. So we right there where we somewhere around 0.3, 0.5 or lower. Well within that. So I might just go through and check a couple of these others since they are electrolytic. They do still have something to do with that circuit. 0.075, as small as that is, it's got to be really good. 2.5 for that little small one. That's still really good. Of course, the smaller a cap is, you know, the higher ESR it can have. The lower the voltage and the lower the value. 6.7. Everything's looking good here. 0.07. Yeah, 4.4. And this, I don't think I did this one. 0.23. So all the other electrolytics show good. It's just that one. So we'll fire up the soldering iron and we'll get it out of there. I have put circles around the caps before I started the video, back testing the caps so it'll be easier to find them. So I know that the cap we got, the actual C201, is right here. That glue is kind of hard. I just moved it back and forth and popped it loose, so it's free. We'll just get it desoldered. Alright, it's out of there. Just that easy. So there we go. You can see that bulge a little better. It's not as bad as I've ever seen it. I have seen some blew out, but definitely had a bulge and definitely had an ESR issue, which is not good. Of course, we want to observe a polarity. Our negative goes towards me. All right. A little bit different size capacitor, but it's not going to hurt anything. There we go. There's our new cap in place. I'm going to put it back together after I cut the leads and test it out, and then I'll put some hot glue. If it tests okay, I'll put some hot glue on the cap to keep it from moving. .01 or .005, really good. All right, moment of truth. Hey, we're charging. says it's full. It actually was fully charged. It charged fine in the charge out in the garage. So let's check one more here. Neither one would charge early without showing defective pack. Awesome. I think we got it. It was just that cap. So all I got left to do, of course, is put the 4 screws and the rubber pads back on it. If you like the video on this Ryobi Charge Center repair, please like, share, and subscribe. Thanks for watching.